Hello, everyone, and welcome to this new episode of Mastering Event-Driven Orchestrations series. Even if we talked a lot during the previous sessions about how to automate the execution of distributed systems and avoid human labor, we will see today how we can bring back the human in these orchestrations and why and when it is necessary. But first, let's do a quick recap on orchestration and what it brings to developers. Orchestrations are composed of tasks that can be arranged in various ways to create complex workflows. Tasks are the basic building blocks of an orchestration. They represent units of work, such as sending a message, processing data, or calling a service. Tasks can be arranged in series where each task is executed sequentially, one after the other. This is useful when tasks depend on the output of previous tasks. For example, in a payment workflow, you might first call the payment service and then send a notification to the user with the transaction ID sent back by the payment service. Tasks can also be arranged in parallel, where multiple tasks are executed simultaneously. This is useful when tasks are independent and can be performed concurrently. For example, in a system monitoring workflow, you might check the status of multiple services at the same time and continue the flow when all tasks or just a subset of tasks are completed. In addition to tasks, orchestrations can include structures of control, such as loop and conditional branching, to handle more complex workflows. A loop allows a task or set of tasks to be repeated until a certain condition is met. For example, in a data collection workflow, you might want to keep collecting data until a certain amount has been gathered. Conditional branching allows the workflow to branch based on certain conditions. For example, in an order processing workflow, you might want to handle orders differently based on their total value. If the total value is above a certain threshold, the order might be sent for manual review. Otherwise, it might be automatically approved. There are also important concepts that help ensure the reliability and scalability of orchestrated workflows. Rate limiting is the practice of controlling the rate at which tasks are executed. This can be useful for preventing overloading of downstream systems, managing resources usage, or controlling the pace of a workflow. For example, in a data processing workflow, you might limit the rate at which data is sent to the database to prevent overloading. Timeouts are used to specify the maximum amount of time a task is allowed to run. If a task exceeds its timeout, it is terminated. Timeouts can help prevent workflows from getting stuck due to slow or unresponsive tasks. For example, in a service call task, you might set a timer to ensure that the workflow doesn't wait indefinitely for a response. Failure handling refers to the strategies used to handle task failures. These can include retrying the task, skipping the task, terminating the workflow, or branching the specific workflow to a specific workflow, to manage compensations. The appropriate strategy depends on the nature of the task and the impact of its failure. For example, in an order payment processing task, you might choose to execute a specific workflow to cancel properly the order and alerting the user. One of the key advantages of implementing application logic in workflows is the ability to introspect the path of task execution. Visualize the workflow timeline and quickly identify and troubleshoot issues. In case of task failures, the task is visually identified and Conductor lets you dig into the task execution to see its input and output payloads and the execution log. This greatly simplifies troubleshooting, as you can quickly understand the cause of the failure and take appropriate action. So to summarize, orchestration refers to the technique of automating processes of distributed applications. The main component is called a workflow, and it represents a suite of tasks and structures of control, plus dedicated features such as rate limiting, timeout, and failure management. The outcome provides scalable and durable applications. But to achieve orchestration, you have to rely on an orchestration platform. And in this presentation, we use Orchest Conductor, an enterprise class orchestration platform built from the successful open source Netflix Conductor. At the core resides a workflow engine that is surrounded by task service manager and scheduler. Each task is backed by a queue, and state is maintained by Conductor. Leveraging its origin at Netflix, where the context was to scale the microservices consumption, Conductor is able to manage millions of tasks and workflow executions to give applications the robustness they need. Conductor is open to external queuing system to easily integrate with other existing systems and offers an API from which are connected Conductor UI that we'll see in a few during the live demo, as well as task workers that developers can code in any language and deploy anywhere. Conductor helps setting up a real distributed system infrastructure. So what kind of task developer can use? First, you have the system tasks. Understand the ones provided out of the box with Conductor, like coding a REST API, trigger an event in a real-time event system, react from a webhook call, etc. The second, and to manage special routing between tasks, we have controls of our operators such as switch to conditionally execute tasks, loop to repeat task executions, forks to execute tasks in parallel, and task to call sub-workflows. Arrive then task workers, the tasks that are coded by developers and tasks dedicated to build AI agent with integrations with AI providers and their LLMs, as well as vector databases. In addition to all of these tasks, Conductor offers another type of task called human task. Let's see in details what it brings to orchestration. In the context of orchestration using Conductor, a human task is a specific type of task that requires manual intervention or approval from a human operator. These tasks are integrated into automated workflows to handle scenarios where human judgment, approval, or action is necessary. Approval workflows, human tasks can be used to obtain approvals for critical actions such as deploying code to production, executing financial transactions, or granting access permissions. This ensures that important decisions are reviewed and approved by an authorized personnel. Exception handling, when automated processes encounter exceptions or errors that cannot be resolved programmatically. Human tasks can be used to notify operators to take corrective actions. This helps in managing edge cases and unexpected issues. Compliance and auditing, human tasks can be used to enforce compliance with regulatory requirements or internal policies. By incorporating manual checks and approvals, organizations can ensure that their workflows adhere to necessary standards and can be audited effectively. Quality assurance. In scenarios where automated tests cannot be fully verified, and the human task can be used to perform manual quality assurance checks. This is particularly useful in complex workflows where human intuition and judgment are valuable. Flexibility. Human tasks allow for greater flexibility in workflows. They can be used to handle situations where the exact steps cannot be predetermined and require human input to proceed. And collaboration. Human tasks facilitate collaboration between different teams and stakeholders. They can be used to hand off tasks to specify individuals or groups, ensuring that the right people are involved at the right time. Whereas workflows manage their own life cycle, human task also brings a dedicated life cycle from the time they are created to their completion. The life cycle is initiated since the human task is created, and the task needs to be assigned to a user or a group of users. Then two options are possible. First, the user claims to accept the assignment or revert back the assignment step. Finally, the assigned user is in charge of the completion of the task and must submit, usually with some data, to mark the task as completed so that the flow can continue. All right, so let's see how to use human task over a concrete use case, a support ticket management. I'm going to pause the slide and switch to the live demo now. And for that, I'm going to go to the conductor UI. Just hold on a second. Yeah, here. And I'm going to load one of my workflow that I prepared for the demo. It's ticket management. So as you can see here, we have a flow with multiple tasks and a structure of control with a branch. So let's see in detail what it means. So the first thing that this workflow is doing is to create the ticket. So there is a ticket we call a service, external service, and the service is going to create in the ticket management database with the issue of the ticket and a potential URL that could be attached to that issue. Then we have another step that is assign a number, like a ticket number. And this, for the sake of the demo, has been hard-coded with an inline function here that I coded in JavaScript that just returns 1, 2, 3. Then there is a task, and you can see here with the little label human, that is actually a human task, meaning that a human will interact in the workflow and will be assigned to that task. So this is to answer the ticket. And for that, we have what we call a UI template, which is a form, and I'm going to see the form in a minute. And there is an assignment policy. As you can see, you have multiple user types that you can assign to. It can be a conductor user, meaning a user that has access to this UI console, or it can be a conductor group, meaning a group that is defined in the groups accessing this UI console as well, or it can be external user or external group. That would mean that your application and its front end will have to deal with the assignment. For this demo, I use a conductor user and I assign it to myself. So I put my email address. You can see also that we can give some SLA if we need to respect, in the case of a ticket management, that's very actually relevant. If you have a contract with your customers where SLA has to be respected, you can put the SLA here. What do we do after the assignment? We leave it open, meaning that the user that is assigned will have to complete the task for the flow to continue. Or we can say, no, the assignment is done, we just terminate the task. And we have some input parameters that will be actually the field of the form that will be associated to this task. So we have here the answer, we have a field escalation or not, meaning like there is a Boolean, and we have the ticket number that we will retrieve from the assigned number output. You can see here the value is assigned here from the previous task. And this is the issue that will be actually one of the input value of the workflow. So once I done this, I can see that this has been attached to a UI template, understanding the form that is named answer ticket form. Let's go and see the user forms here and see the answer ticket form. The answer ticket form has a ticket number. I can see the detail of the ticket number. It is a read-only field. And we have the issue that is just a text. And we have the answer that will be the field where the user will have to answer to the issue. If the user is unable really to give an issue, it can say need escalation. That will be just a Boolean, so it's represented by a checkbox. Let's go back to the flow. So once the form is submitted, the task is completed, we have a switch here that will actually see the field escalation value. We put it in a key called escalation. And if escalation is true, we go to that route that will actually trigger another assignment of another human task. That will be escalate answer ticket. And escalate answer ticket form is assigned as a UI template. And with the same kind of binding between the value of what has been done previously and the parameter of this form. And if I go to the user form, I can see escalate answer ticket form as the ticket number, the issue, and the answer. Of course, there is no escalation in that case. Let's go back to the workflow once again. In both cases, except in that case, there is an escalation form that is done. We are setting the answer. So set answer and set escalate answer that will position a variable called answer with the output of what has been fulfilled by the user. In that case, it will be in this form. If there is escalation, it will be from the escalate answer output. So we have the answer, we can reply to the user, but Conductor has also some integrations that are pretty interesting. I can see it here, not especially with AI providers and their LLMs. So you can see we have Azure and OpenAI, we have Google Gemini, Cohere, Anthropic, AWS Bedrock, Hugging Face, Mistral, as well as vector databases for AI. But in our case here, we go back to the workflow. What we're going to do is doing a text compilation with a LLM provider. The provider will be Mistral, and we're going to use the model Mistral Large Latest. So what we're going to have here is we're going to use the answer from the variable, and we're going to use that in a prompt that will be given to the LLM. So here you see prompt template is I want the correct answer. So let's see what the prompt is doing, is giving to the LLM. AI prompt, correct answer. The only thing is rephrase, fix, and complete the text in a variable called answer by giving additional details. So this is really an example where we can see how to create a workflow that can be integrated very easily in your existing application, where you add automatic processes to call with your ticketing management system and have a number assigned to the ticket and ask a human to answer. And when it's that, we can help this answer to be completed with an AI model in order to give something to the user that is very complete. So let's execute it. I'm going to come here and I'm going to say, I'm going to go to my workflow and sorry, I'm going to run it. To execute a workflow becomes a service, right? So it's just an API call, or if you use one of the SDK that is provided with Conductor, you can integrate it really in your Python app, JavaScript app, Java app, Go app, or whatever language you're using, C#. I forgot this one. So here, but for the sake of the demo, I'm going to do it directly inside the UI console. As an input parameter of my workflow, I have the issue. And as an example, does Python support arrays? So let's run this workflow. We run the workflow, we create the ticket. Let me refresh. Ticket has been made, and assign number has been done as well. I can introspect what has been done. The output is 1, 2, 3. So we have a ticket 1, 2, 3. But here there is answer the ticket, and because it's a human task, the flow is paused right now until this task is completed. As a user, I can go to human task in the execution part, and I can see that there is something assigned to me, and the name is answer. So I'm going to click on the task ID, and I'm going to see the form with the ticket number and the issue. And I'm going to say, what is the answer? So first, the first thing, remember that tasks have their dedicated life cycle. I can say, all right, I'm going to claim it. By claiming, I'm going to have access to the form, and I can now go inside the answer and type my answer. What I can do here is to say, yes, Python supports arrays. And I don't need escalation because I know the answer. And I complete the task, meaning I'm going to submit this. And because I submitted this, I can go back to the workflow execution and see that it was still running. So we went there. There is no escalation. It went to the LLM complete. If I refresh, LLM has been executed properly, and I can see the result. Let's see the output. Yes, Python supports array, but it's important to note that the standard Python library does not include a built-in array data structure like some other programming languages, etc., etc. So I have a very complete examples. Also, it includes like code samples, how to do it in Python. This is what the LLM helped me to do just by answering this little question. And I can introspect the timeline of this execution. That can be quite interesting as well. I can see that it took to answer the ticket 1 minute and 36 seconds, because this was the time between the creation of the task, a human task, the user saw and got notified, claimed the task and answer. This is the time that has been put to execute the task itself. So that's pretty interesting because you know exactly where it is. Let's say there is a 3 days delay to execute the task. This is probably somewhere where you can improve the flow of your workflow, meaning like putting a timeout if this task hasn't been claimed after a certain period of time, then it automatically escalate to someone, or you can define anything you want in that case. Let's go back and do another execution. I'm going to go to run again. And we're going to say does Java supports array. And I'm going to execute this. So it's the same execution. We're going to create the ticket, assignment, and now I have this human task. I can go to the workflow, the human task. I can see that this has been assigned. You can see the previous one has been completed. This one has been assigned. I go, does Java support array? I'm going to claim, and I'm going to say, not sure, and I need for that an escalation. So I'm going to complete the task. Now, if I introspect the execution, still running, and we can see that we went to that branch. And we are now in another assignment of another human task that is escalate answer. So I'm going to go back to human task, and I'm going to see, yeah, escalate answer is assigned to me. And I click. I see that does Java support array is the issue, but the first answer done is not sure. So I'm going to claim it, and I'm going to rephrase to say, yes, Java supports arrays. Complete. Go back to the execution. And now we're going to refresh to see if the LLM finished. Yeah. So I'm going to see the output. Yes, Java supports array. Arrays in Java are used to store multiple items in a single variable. They are objects that store multiple variables of the same type, etc., etc. So as you can see, we mixed in the same execution, in the same orchestration here, calling services, asking a human to interact, and calling LLM to help us to answer to our client efficiently with a lot of details. Of course, I can adapt the prompt and do something more complex in order to have an answer that is even more complex, or I can come here in the definition and say, actually here, we're going to do a fork. And the fork will have multiple branches. And in parallel, I'm going to call, I'm going to just put HTTP task here, but just to show you that the way we do it. So here I can run in parallel multiple tasks, and that can be actually multiple AI LLM that we can query and pick the best answer after that, and make a kind of competition between LLMs. That could be fun. So as you can see, pretty easy to build, pretty easy to use. One thing I wanted to say also, because that is a common question that comes up when we show the human task, is I'm going to discard those changes. For the user form, the way to design a form, so we have access to some component here. We can put, like, if we want a date, we just put it somewhere, and then we have a date that will come with a calendar. Everything that is defined here visually is actually also a definition by code. And this is compliant with a library called JSON form. So JSON form actually is something that you can integrate in any application, React application from your front end with this little object component. And the component has multiple properties, UI schema and schema, which is exactly what you need. As you can see here, this is exactly what is given here. And our SDK is helping you to grab that directly when your application make a connection to Conductor, so that you grab it and you can use it automatically. But just for the rendering, this is something totally standard used with JSON forms. Or you can build your own components, of course, and use just the API to submit the value of the form. All right. This is the end of the demo. And of course, if you have questions, you can always come back to me. Conductor is an open source, can be retrieved on GitHub with github.com/conductor/OSS Conductor. We are very happy because we have a lot of stars that has been given by the developer community. We are almost at 18,000 right now, but it's never enough. So if you like the presentation, if you like the demo, go to Conductor and give it a star. It will make it even more famous. All right. Thank you very much for your participation today. I hope it was insightful, and I will tell you have a good day and see you for the next episode of the series. Thank you.